I'm Carl Victor. Will provide some insight into the exciting topic of presses and focus on some press control. Appreciate your time today, and we also value your time, so we're trying to keep this to around that 30-minute window. We'll be talking about presses, types of actuation in presses, considerations in pressing, what to think through when you're selecting a press, and how Kyntronics is your likely ideal press solution. So there are all kinds of different presses out there, as you know. Looking around the room that you are in right now, presses were likely involved in most everything in that room, one way or the other. Presses are in most factories out there. Just look around and you'll see them. Assembly presses, of course, just doing that, assembling pieces, parts together, bearings, that sort of thing. Punching, piercing, forming presses. Sometimes they're in a line, producing a product at the end. Flaring is another interesting solution. They use a lot of times they use hydraulics, some higher loads there. Insertion, stamping, shearing presses, molding and injections, a different type of control there. And you got your fatigue, your testing materials, that sort of thing. All kinds of industries, of course. There's just a few. Automotive uses a lot of assembly presses. They like the quality checks on those presses. We'll talk about that. Aerospace, military, do the same thing. Again, all kinds of different presses and industries. So some considerations when you're developing a press solution. Load, speed, stroke are usually the first three to start out with, especially on budgetary or just getting some things going. These others on the list evolves, and you can include them. I'll kind of quickly go through them. But load and speed are the big dollar items. They're the items that cost some or can move the needle one way or the other regarding the dollars. So if there is, for example, a 2-ton requirement from a customer running at 2 inches a second. Let's say the customer has that press running today, but they say, hey, I want to go to 4 inches a second instead of 2 inches a second. Well, you just doubled the horsepower, doubled the motor size, doubled the drive size. And if they say on top of that, they want to increase from 2 tons to 3 tons, well, that's a 50% increase. Now you did a 150% increase. So a lot of times people throw out numbers and don't really think about the repercussions, and those obviously add a lot of cost. Stroke doesn't add a lot of cost. With our system, we can go by the millimeter. Some of the others are various chunks, so that needs to be a consideration on the stroke. Force zone means where in the stroke does the force usually get applied. Sometimes most of the time it's not all the way through the zone. Usually it's at the end. Cycle times, of course, is part of that important aspect that the customer is looking to obtain. So the other items, again, as we go through the project, we're looking to optimize the solution, tooling weights, no load speed, those sort of things. Short stroking is an important aspect. A lot of hydraulics, most of the cylinders, they go either extend or retract. Let's say it's an 8-inch stroke. You need the 8 inches for getting out of the way for the tooling or things like that, but it still needs to travel that, so that adds extra time to the cycle time. With our system and a lot of the electromechanical type systems that are controlled, you can short stroke. So, for example, if you're only using the last inch or half inch or so for doing the press, you can start at 2 inches and work from there, eliminating the other 6 inches. So that helps on cycle times. Orientation, if it's pointing down, you may want to lock it for safety reasons, those sort of things. So control, we have various modes of control: position with force limit and force control. We'll talk about those, as well as synchronizing. So these are all things to consider while you're going through and figuring out what the right solution is on your press. So some of the different actuator technologies that are out there are air of oil, electromechanical, and hydraulic are the popular technologies. Air of oil is relatively simple. It uses air as its power source. So it doesn't have the motor and associated drive, so it's a little more cost-effective solution. But with that, you lose some of the control capabilities, of course. There's maintenance. You have the compressor running all day long, energy inefficiencies and those sort of things associated with that. And of course, as I mentioned, you lose some of the control capabilities and short stroking and various force modes and things like that. Electromechanical, it's a very efficient solution, power on demand. You have your accurate control. You have fully controlled throughout the stroke. Some are shock loads are an issue with electromechanical as they're mechanical wear items. With that said, they all have limited life. And when that $10,000 actuator is done with its mechanical items, unfortunately, you got to throw it away and get a new one. With the hydraulics, it's large loads. It's used all over the place in high-speed type applications. For example, if there's a 100,000-pound force load, 50 tons, running at 10 inches a second, it needs like a 200 horsepower motor to make that happen. And that's on a lot of presses. That's ideal for the hydraulic world. You can't put a 200 horsepower motor on the back of a little electromechanical actuator. So they all have their places in the world. And on hydraulics, of course, you got environmental considerations. Efficiency is a very inefficient solution, and it gets very costly if you need some sophisticated controls. So electromechanical, hydraulic are the most popular items out there that technologies out there that run presses and operate presses. And that's where we come in. So our hybrid solution combines those two proven technologies. The power on demand is there, the diagnostics, etc. All the ease of control is there, just like the electromechanical in our hybrid solution. We're also shock load tolerant. We have no issues with shock loads, just like the hydraulics, high IP ratings, and all the associated benefits on hydraulics. We'll get into some of those. And eliminates a lot of those shortcomings and challenges, as just mentioned, including, the metal wear, those sort of things. So looking under the hood a little bit with our product, a lot of you are familiar with it, just so I'll go through this relatively quick, but it's basically converting the rotary motion of the motor, servo motor, into hydraulic ram press. It's ideal. You don't have the metal wear, those sort of things. You don't have a lot to go wrong. So it's a very simple design. And as I mentioned, opposed to the electromechanical, where if something happens to it, you got to throw it away. With our solution, you got to replace some seals. Even if you send it back to us, we can update the seals, etc. And you'll have just like a brand new unit ready to go. So you don't have to throw the actuator away. If you spend the money on the actuator, it's yours and it can be repaired. So it's a smart actuator, and we'll get into using these feedback devices here in a little bit. So the pressure sensor is force equals area times PSI. It gives you the force right at the rod itself. Other methods are torque calculations to try to understand what the torques are and forces are, but this is actual area times PSI, therefore very close to what the force is on the end of the rod. You can have an external position sensor or an internal position sensor, giving you that position feedback, and it's connected right to the rod itself. Some of the electromechanical, you have your encoder and then belts and gears and all kinds of backlash, so you lose your accuracy. So we're controlling right there, right on the rod itself, again, giving you the little more accurate position. Some of the hybrid characteristics of the fluid, some of you are aware of it, some may not be. Let's kind of go through some of these. So it's basically incompressible fluid, nothing's totally, but for most of the applications, the forces involved don't compress the fluid, so you don't have the backlash. Shock loads tolerable. So shock loads are not an issue with our unit. We need to keep the fluid inside. Therefore, we have high IP ratings. We can go up to the IP69. Force control, I mentioned. Counterbalance valve is a nice little feature that helps out in a little more cost-effective solution. So it can lock, it can help on control things, controlling like overriding loads and those sort of uh, characteristics. Relief valves to protect the actuator and machine. As I mentioned, there are repairable solutions. Float mode is a nice little feature. You can share the fluid from both sides of the piston, so you can move the rod back and forth very easily. Configurable, as you can see, there's all kinds of different configurations. It's just fluid moving, so if there's a tight fit into the machine, we can get pretty clever to fit the actuator into the machine with these various configurations. Also manual operation, flow control. For some presses, you want to go, let's say, 5 inches a second, and then you want to go 5 inches per minute or a half an inch per minute, really, really slow. So we can do that by diverting flow and doing some flow control there. Also, with fluids, you can do multiple cylinders to increase speed, multiple pumps, or even power units. So you have some flexibility with hydraulics to add flow and increase your speeds as needed. The last on that list is you can have a separate power unit and cylinder. So you put the cylinder into tight space, and you're going to have a separate power unit with some hoses going to that, and we'll talk about that a little bit later. So again, there's a lot of nice benefits with hydraulics. Sometimes hydraulics get some negative connotation, but if you use them correctly and you can harness that technology, you have some nice advantages to solve some problems out there. So I'm going to go through some pressing examples with various control modes. Assembly presses, position control with force limit, kind of explain what that mode is, locking with torque memory, some long press times, pressing to a force control by itself, and some high-speed position and clamping modes. We'll talk about that. And then another mode is the constant speed with extrusion or injection molding and those sort of things. So the first one's an assembly press. So basically what an assembly press does, of course, it assembles things. You can see the picture in the right-hand corner. This is a couple pieces for a transmission. You put them together. It took about 40,000 pound force. So these are some of the considerations, of course, with tolerances. Sometimes the parts aren't made exactly to the tolerance stack up, and pressing may require much more than 40,000 pounds. So you need those quality checks, data logging, those sort of things. So our solution provided the actuator that can provide the 40,000 pound force capability. It had position control. It also had the force control. And we went into the mode of position with force limit. So what is that? So you can go to a position, you have to have a target position with a force limit. So as you're moving down at your desired speed, and pressing these parts together, if you see a force limit as you set above 40,000, say 45,000, it'll switch into force mode, and it will not go over that limit, and you can then flag it as a bad part or something like that. So it'll protect the machine, won't damage the dies, won't damage the equipment or the actuator. And again, the control checks, go, no go type thing will be sent up. So that's the force limit. Again, it converts from position control to force control, bumpless, and it'll apply the force. So there could be other applications of presses that require that mode as well. Next is extended pressing. This is kind of a unique control mode, locking with torque memory. So in this particular example, some of the considerations, again, a long period of time, could be 30 minutes, could be hours, could even be days in some instances, in some testing situations. This particular one, I think it runs for about 30 minutes. There's 33 actuators up here, 60-ton actuators, and they're pressing a beam. For example, if you have a 2x6, several 2x6s with glue in between them, you're pressing that particular beam or making the beam, pressing that wood together. And it takes 30 minutes or so. So some of the considerations, actuator fatigue, energy, monitoring, force and position, quality checks, those sort of things. And I'm able to adjust the force on any actuator at any time to your desired profile. So our solution was a 60,000 pound force solution. Position control, force control. So if they went down the road of hydraulics, it had to be 33 cylinders, big, huge hydraulic solution that's pumping all day long, taking a lot of energy for those 30 minutes and pressing that 60-ton each actuator and having the flexible control is a challenge. So our solution, how it works is it'll go to the desired force. First, it'll do the position control, touch the product, go to force mode, and once you're at that 60 tons, it'll memorize the torque of the motor that produced that 60 tons, and then it'll lock the solenoid and turn off the motor. So now you're not using any energy, holds the motor until it gets out of a certain window. Let's say it's goes to 118,000 pounds or something like that. So if it drifts outside the window, the motor will then go up to the memorized force, then release the solenoid, then slowly ramp it up back to the 120,000 pounds inside the window and shut off and rememorize and shut it off. So what that does in those 30 minutes, you're probably running the motor less than a minute and not using a lot of energy. It's a bumpless transfer, so you don't get these large bumps going from turning on and off the solenoid. So it's a unique solution for all kinds of different applications out there. This one particular one's in lumber. We've done it in bearing tests. We've done it in fatigue testing and for materials, those sort of things. So anyway, there's another control mode. Pressing to a force is another unique, different control mode that's available with our solutions. Some of the considerations, again, programmable force, adjustable speeds. So once you go into force mode, it'll go to whatever speed you have listed. Slow pressing, those sort of things. Monitor position during the press, so you have that feedback. So you have both position and force feedback devices. So in this example, this is actually a weld. So during the weld, you want to maintain a certain force. And as the weld is produced, obviously the force is going to change. So you want to maintain it, and it'll go in a little bit slowly. And so it's critical on some of those important welds and quality checks. So again, force mode. Clamping is another different type of application. This one particular one is if you needed to quickly get into position and clamp. Mechanics don't like the clamping too much because you got all the clamping situation pushing against all those roller bearings and ball screws and everything else. With hydraulics, as I mentioned, it's pretty incompressible, doesn't care about the shock load, so it's really ideal for clamping. But in some of these blow molding and other examples, you got to quickly get in the position. It takes a large horsepower HPU to push. If you need to hold 80,000 pounds, you need a large cylinder to do that. That's a lot of volume, so you have to have a large, again, horsepower motor and large pipes and all those sort of things. With our solution, we can do this high speed, high force. You can do multiple pumps. You can do multiple cylinders. So you can get by, instead of using a 100 horsepower motor to move the fluid around, you can get by with like a 10, 15 horsepower motor. To do that, basically you're going a low load, high speed with a pump or a cylinder, and then you switch over and you do a slow move or just clamping situation. So again, it's an ideal use of hydraulics to meet your high speed needs and clamping needs. and various modes. So this example is extruding, injection pressing type example. This particular one is consistent flow is important in a control world. They want either consistent flow or consistent pressure or a combination of those during the process itself. So we can provide that, especially when you have the pressure sensor, you can give that consistent pressure throughout the process. And each process is going to be different. In the beginning, it's more pressure. At the end, it's less pressure. So it'll constantly adjust to maintain that consistent pressure. So in this one was a 10,000 pound force actuator. You can maintain that a couple thousand PSI. And it's fully programmable as needed, of course. So how do we do all this? As a lot of you know, we can provide the complete solution with position control, force control, position with force limit, those sort of things. We can provide the actuator with the servo motor. We'll properly size things for you. Provide the drive on a panel. It could be inside of an enclosure or part of multiple drives itself. The nice thing is it's our software. With our software, we can provide the support, remote support, phone call. We can help dig in, and we can go online and connect to the computer and even look what's going on there, change, tune this or do that. And of course, you got the field bus connectivity capabilities to pretty much any PLC that's out there. And it's one-stop shopping, provide you all the documentation as needed and support. And again, that software with everything I just mentioned, the various control modes are all selectable for your press application. And you can even go from one control mode to the other. So it's all, select a 1, 2, or 3, and you're off and running. So for those of you out there that use the Rockwell system, we have an AOI with that same software. So the AOI is, all that software was plugged into the AOI. So you have all those capabilities along with some other capabilities, including auto tuning, you have multiple gear sets, gain sets. You can do synchronizing and all sort of things with the AOI itself. We have some example code. And below the dotted line, you have the Kyntronics solution that can talk Ethernet IP that will do the implicit messages or explicit messages as needed. Again, both are easily supported from our experts here at the factory. So in the press world, we can provide an HMI. It can be a standalone, or the HMI can provide the field bus connectivity to whatever PLC that's out there, or master controller. So again, this is standard software. We can do the more cost-effective 7-inch touchscreen. It goes onto the panel, or it could be remotely mounted, or we can do the little more sophisticated PC-based solution. They both have these same capabilities, diagnostics, basically index and sequencing. You can set up your index for various parts that are out there. You can do it based on recipes, but if you have a half dozen different parts that are being run and each one needs a different force limit or force control or whatever else is out there, that's all selectable by the operator. You can do your quality checks. So if you exceed that 40,000 pound force, you can flag and stop the process however you want to do that. And you have the data logging as well. So again, all standard, ready to go. For your press solution, can be standalone or it can integrate into your existing PLC. So high level wise, it's looking at, we have our SHA product line, and you have your SPU product line. The SHA product line is your self-contained hybrid solution. We can provide the actuator only, we can provide it with a motor, or we can provide it with a motor and drive. Power on demand, so our standard product goes up to 75 tons, 150,000 pound force. We can do any stroke. We've done up to 120 inches. The SPU is a little different product. We'll get in a little bit. It separates the power unit and the cylinder itself. And we can provide it with the cylinder, drive, motor, any combinations of those. The servo power unit, just wanted to share with you all, it's somewhat of a different, unique product that's out there, and we continue to enhance it. But it's getting more and more popular. It's a very easy stepping stone. If there's a cylinder tucked into the machine, let's say flaring machine or whatever that's out there, or your press, you can keep the cylinders, use the power unit, have all those control capabilities that I mentioned. There's three basic standards here. You have your single standard that can run a single cylinder or a rotary motor. You have your multiple power units, as I mentioned, the capabilities of fluid. You can add power units. This one shows 2. We've done 5. We've done 6. So that adds the flow, so you can run a 8-inch cylinder at 4 or 5 inches a second. And then you have your multiple outputs independently controlled. This one shows a valve, but this is ideal for some clamping applications, those sort of things. Replaces HPUs out there. So anyway, there's a lot of capabilities with the SPU. And again, you have all your control capabilities that I went through in various examples with the SPU itself. So just wanted to, we're almost wrapping up here. Just wanted to show you some more high-level pressing type examples, successes that we've had. So the tile press, this isn't for your floors. This gets a trip into space. This is on the Starship. So this is doing some nice pressing, and they love it there at SpaceX. The next one's a frame press. You can see there's coordinated motion here, synchronizing a couple actuators together, bending a frame press, staying on that same thing, multiple cylinder press. You can have multiple cylinders. This example can run from the SPUs, coordinating motion, synchronizing together. You got your hub press. This one to the right is actually a line. I mentioned you're punching, piercing, clamping, bending. It's all in this line. So it starts with a sheet of metal. It ends with a side panel for an appliance, all produced as needed. So again, punching, piercing, all kinds of different pressing modes in this particular line. Forming press, clinch press, a ring press, your die cutting for a blister pack. So all kinds of different types of presses. Wanted to share we've done all these, and the control for these, we're familiar with it, and we're just not an actuator producer. We like to provide those solutions. So as I mentioned, the control solutions, we've done them all. We're familiar with them all. We know what to look for. We know how to solve problems out there. It's a differentiating actuation solution. So if there's an OEM looking for to separate themselves, that's our solution. We do make the complex simple. We're used to that. That's what we do. Reliable, efficient, etc. So if you have any questions, let us know. Look forward to solving problems and working with you in the future.